SwayamPrabha. Digital India. Educated India.
So, friends, we are talking about aggregate production planning in our course on production and operations management. Aggregate production planning, as we have seen in our first session on this topic, this is the second session on this topic. We have seen the importance of aggregate planning and how this is a part of a bigger aspect, that is production planning and control. Aggregate planning is a medium range production plan spanning from 1 quarter to 6 quarters or 8 quarters, that is 3 months to 18 months, 24 months. And in this we try to see the, and the name aggregate is, we try to see the whole production requirement from an aggregate perspective rather than on a different models of perspective. So, we see that whatsoever total production need to be produced based on that aggregate demand of various models, etcetera. We try to see that the production plan for aggregate demand of different models. There we also talked about what are the various alternatives, options available with us, proactive approach and reactive approach. In the proactive approach, we try to see that my demand is more uniform. I will try to shift the demand from peaks to valleys, and in the reactive approach, whatsoever remaining imbalance is there, remaining variation is there in the demand, I try to see that how to meet that by the change strategies and level strategies or mixed strategies. We also talked about what are the various input parameters which are required and what are the various reports, output which are get produced with the help of aggregate production planning. In this particular session, we are talking about few illustrations where we will see the application of those aspects which we have covered in our first session. So, the complete process, if we see that by combining all which we have studied in our previous session, first step in this aggregate planning is determine the demand for each period. Suppose my planning period is planning horizon is 8 periods, 8 quarters, or it can be 8 months or 12 months. So, I have to see how much is the demand in each of these periods. The demand can be based on the forecast, demand can be based on the actual orders also. Then I have to see that capacity and production rate for each period, how much capacity I am having in each period and what production rates I can achieve in each period. Then I have to see that what are the policies which are available with me, whether I am having some contracting available, can I increase my manpower, do I have the necessary funds to keep inventories, can I go for the shortage. So, like that. So, these are some of the policies which are at my hand, we can call it strategies. What are the various strategies which can be exploited, which can be leveraged to meet the demand. Then I have to see that what is the per unit cost. If I go for a regular capacity production, if I go for overtime, if I go for subcontracting and so on. Then based on these input parameters, these are some kind of a input parameters for our production planning. I will develop the alternate plans and determine their costs. Then I have to select the best plan which satisfies the objectives, that is generally minimize the cost. We have seen the various objectives also, like minimize cost, maximize profit, maintain a stable production rate, maintain a stable workforce level, maximum customer service also. But here in our illustrations, we will use minimize lowest cost as one as objective, that is more tangible objective. So, there are several methods available, lot of research is there in this area, but to understand the topic we will talk about 3 models. One, we will use the spreadsheet. It can be done manually, we can do it, we are doing it manually, but we can use the Excel or some other database spreadsheet for this purpose. We will also talk about then linear programming modeling, how to develop the aggregate planning problem as a linear programming problem, and also we will see one illustration of how to develop the aggregate planning problem as a transportation model. We will have some discussion on simulation or computerized models where I can do the trial and errors also, I can check various alternatives, I can generate different scenarios, I can examine various external parameters also to see that what is best in the given conditions. So, but obviously simulation will not give the optimal answer, whereas spreadsheet, linear programming and transportation will give you the more optimal answer. Let us see first the spreadsheet approach to aggregate planning. So, what we need to have? We should have forecast the demand for each period, determine the capacity, regular time capacity, overtime capacity, subcontracting for each period, determine the labor cost, hiring cost, firing cost and inventory holding cost, and consider the company policies which may apply to the workers or to the stock levels, and then develop the alternative plans and examine their total cost. Let us take one small illustration, that is 4 quarters only, 1 year planning, where we are having 4 quarters. In the first quarter, my forecast, the demand is 1 lakh unit, 100K thousand. In the second quarter, the demand is 60K. In the third quarter, demand is 120K, and in the fourth quarter, the demand is 160K. So, you will find that demand is fluctuating from 60 to 160,000 in these 4 quarters. The hiring cost is rupees 1000 per worker. We have taken, for the sake of convenience, we have taken the lower numbers. So, that idea is to explain the concept. You may add one more 0 also, depending upon whatsoever it is. So, do not go by the absolute number, try to understand the concept and how to do the analysis of this. Layoff cost, we have considered 5000 per worker. It can be 5 lakh also, it can be 50,000 also, depending upon the skill of the worker, nature of the worker, agreement with the worker. Inventory carrying cost, again depending upon the unit cost of the item. If it is a bigger item of few thousand rupees, it will be more, but for the sake of keeping the numbers low, we have kept rupees 4 per unit per quarter, and then the production per employee is 1000 units per quarter, and beginning workforce is 110 workers. To start with, I am having 110 workers. So, with these input parameters, let us see the various strategies, analysis of the various strategies. First, let us see the change strategy. In the change strategy, if you recollect, we produce, our production rate is equivalent to the demand. My demand is production is equal to, in the change strategy, the production is equal to the demand. So, that is changing, my production changes the demand. So, in the first quarter, demand is 100,000. So, my production is also 100,000. In the second, the demand is 60,000, production is also 60,000. In the third quarter, demand is 120,000 K, the production is also 120 K. In the fourth, the total demand is 440,000. So, my total production is also 440,000. Now, if you recollect, our initial number of workers is 110. So, to produce and each worker has a capacity to produce 1000 units per quarter. Okay. So, I need 100 workers only to produce 100,000 units. So, I have to lay off 10 workers. In the second quarter, my demand is 60,000, production is also 60,000, I need only 60 workers. So, 40 workers I have to lay off. In the third quarter, the demand increased to 120 K, the production is also 120 K, I need 120 workers. So, I have to hire, at present I am having 60 workers, so I have to add 60 more workers to make it 120. In the fourth quarter, the demand is 160 K, production is 160 K, I need 160 workers. So, I need to hire another 40 workers. So, in total I am hiring 100 additional workers, and each worker hiring cost is rupees 1000. So, 1 lakh is my hiring cost. On the other side, I am laying off 50 workers, and each layoff cost me rupees 5000. So, 2,50,000 is the cost of layoff. Together if I operate this policy, the total cost is 3,50,000. So, with this illustration we can understand how to calculate the cost of a particular strategy. So, the change strategy costing me 3,50,000. Now, coming to the level production strategy, in this case we produce at a constant production rate. As we have seen, the total production requirement is 440 K, 4,40,000, and we are having 4 quarters. So, in each quarter my requirement is, in each quarter the requirement is 1,10,000 units, 1,10,000 units. Is 1,10,000 units. So, I am putting a level production rate, it is something like this. If we see the graphically, I will produce in every quarter 110,000. In the first quarter the demand is less. So, I am producing the demand is less, and in the second it is further less. So, maybe this is my in the second quarter the demand is further less. In the first quarter we will find that if I produce 110,000 every quarter, in the first quarter my demand is lower than this, and then in the second it further reduced to 60,000, but then it increased to 120, and then I need to have produced 160 units like this. Okay. So, this is going to be my demand pattern, and but my production is uniform. So, what happens in the first quarter? Demand is 100,000, I am producing 110,000. So, there will be an inventory of 10,000 unit. So, this much is the inventory of 10,000 unit is getting created in the first quarter. In the second quarter the demand is 60,000 K, production is 110 K. So, 60,000 additional units are getting manufactured in this particular period. So, that is 60,000 K. In the third quarter we are short of 50,000, we are short of we are still surplus of 50,000, 10,000 which are extra is consumed from 60,000, we are still having a surplus inventory of 50,000. In the fourth quarter the product demand is 160, actual production is 110. So, whatsoever 50,000 we are having as inventory of the previous period, that will get absorbed and we are left with a 0 inventory. So, in that way we are having periods of inventory, and these are the periods when this inventory getting absorbed. And the total inventory in the system is, if we take a total, that is sum of these 4 periods, that is 1,20,000 unit, and we have seen that our cost of carrying inventory is rupees 5 per unit per quarter. So, my total inventory carrying cost is 6 lakh rupees. So, in the change strategy, if you recollect, in the change strategy the cost was 3,50,000, and in the level strategy it is 6 lakhs. Now, see a combination of the two strategies together, that is a mixed strategy. I am not changing, I can change manpower from 90 to 130, I cannot go beyond 130, and I should not reduce below 90 also, and rest of the demand is going to be met through the inventory. Okay. So, that is going to be the system in this mixed strategy case. So, it is a combination of change strategy also, certain part of the variation I am going to change with the help of changing the production rate, other part of the variation I am going to meet through inventory of a level strategy approach. So, again coming back, our first quarter demand is 100,000, second quarter is 60,000, third quarter is 120,000, and fourth quarter is 160,000. And production plan, if you recollect, we are having 110 workers to begin with. So, I am not laying off, I have to keep the worker from 90 to 130. So, I am not laying off the worker, I am producing with the 110 workers, each worker is producing 1000 units. So, my production is 110,000, and worker needed 110, which I am having, and I will build an inventory of 10,000 and there is no layoff. There is no layoff. In the second quarter, the demand is 60,000. So, I will reduce my manpower to 90. I will not reduce to 60 just like in a change strategy. I will reduce to 90 workers and I will produce 90,000 units, and in the process I will produce additional 30,000 units of inventory, 10,000 I was having earlier. So, now total inventory is 40,000. 40,000 will come 10,000 plus the gap of these two is 30,000. So, together 40,000 inventory is there and I have laid off from 110 to. So, this is the number I am getting. I have laid off 20 workers. So, minus 20 is a layoff. If it is a minus, it is a layoff. If it is a plus, that is hiring. In the third quarter, my demand is 120,000. So, I have to increase my manpower to 110. So, that I can build some inventory of 30,000 and which can be required in the fourth quarter also, because I cannot increase my workers to 160. So, I will keep that provision here. So, I will build the inventory here. Demand is 120, I am producing 110. So, 10,000 is consumed from our existing inventory. So, my inventory level reduced to 30,000. In the fourth quarter, demand is 160,000, production is 130,000. I increased my manpower by 20 units, that is reflected here, and 30,000 is the less production I am having as compared to the demand. So, I was having inventory. So, that inventory get absorbed here. So, in totality, if we see that total inventory of the system is 80,000 and 20 workers are layoff and 40 workers are hired. So, together 80,000 units of inventory at the rate of rupees 4 lakh is my inventory carrying cost, 40 units of hiring at the rate of 100 for 40,000, 20 units of layoff out of 5 lakh, 1 lakh, and together these component, that is 4 lakh of inventory carrying cost, 40,000 of hiring cost and 1 lakh of layoff cost. Together the cost of this policy is 5 lakh 40,000. So, if we compare with the previous two policies, here itself we can say mixed strategy, here we can say mixed strategy, that is 5 lakh 40,000. So, in this particular situation we can say that the change strategy is better, because the cost of change strategy is 3 lakh 50,000 as compared, which is lesser than the other two strategies. But again it will depend upon your cost parameters and other things. Here we have considered cost of hiring 1,000, cost of hiring layoff. You can do as a exercise what if analysis. What will happen if hiring cost increase to 2,000 and firing cost increase to 10,000? Friends, we can make a correction here. We have calculated all with the considering rupees 5 per unit per quarter as our inventory carrying cost. If you recollect, we have considered 5 rupees as our inventory carrying cost. Here also we have considered 5 rupees as our inventory carrying cost, and here also we have considered 5 rupees as our inventory carrying cost. So, we can see that if the cost increasing hiring and layoff cost increase to 2,000, 10,000, still the change strategy is good. What is the whether change strategy is still good, or we may find that now change strategy is no more economical, rather some other strategy, maybe a level strategy or a mixed strategy become more viable, less expensive. So, it all will depends upon the cost parameters which we are a particular situation is having. So, this is the spreadsheet method of examining the various policies, and we can examine the advantage of this is we can include every type of reality into this system. Whatsoever option you are having available, if tomorrow you are having subcontracting also, that can also be added in this. One more column will come, and you can examine the subcontracting strategy also. So, whatsoever strategy, whatsoever option you are having, you can with the help of this spreadsheet, you can examine that, see that which particular combination will give you the best answer. So, that is the strength of the spreadsheet. And second important thing is, it is very easy to use and very easy to understand also, whereas the transportation models and linear programming models are bit difficult to model, and then it is very difficult to explain also to the management or to the senior executives or to for the implementation purpose also. In the spreadsheet we can do the what if analysis, as I have said. If we change one number, we can see the impact of this on our policies. We can develop the spreadsheet as exercise. You can develop hold of this in the Excel sheet, and then you try to see that if I change these parameters which are there in our first sheet, and you develop the Excel sheet in such a manner that by changing this one parameter, whole of the calculation getting changed. You should not each cell should be, that means formula based rather than the absolute number. So, even if I change this numbers, if my demand scenario change, then which particular strategy is good, or if there is a change in the production per employee, if there is a change in the cost of carrying inventory, what is its impact on the different strategies you can examine, or if there is a subcontracting also included in this, then you can see that also. Or maybe the another illustration which I am taking of a transportation model, you can try though I am solving this illustration with the help of a transportation model, you can try this as a spreadsheet also. You can try this question as a spreadsheet also. So, that you will get to know that how the two methods can you can see the easy and difficulty of the two methods. So, same way here we are considering again the 4 quarters, and we are having a demand in the first quarter of 300 units per week. In the second quarter, the demand is 800 units per week. In the third quarter, demand is 600 units per week, and in the fourth quarter, demand is 200 units per week. Okay. So, we can consider that, or we can say in absolute also, in the first quarter the demand is 300 units, second quarter demand is 800 units, in the third quarter demand is 600, in the fourth quarter demand is 200, and the total demand is 1700. Then the regular time capacity, you are having again, you are having 300 units regular capacity in quarter 1, in quarter 2 you are having 400 units regular capacity, and so on. Total regular capacity you are having is of 1400 units. Then obviously, the regular time capacity is lesser than the demand. So, I have to see some other capacities also. So, overtime capacity, I can go for 20% of my regular capacity as overtime. So, 20% of 300, that is 60 units I can produce through overtime. Here I can produce 80 units, I can produce 80 units, 60 units, and total 280 units I can produce through overtime also in this planning horizon. I am also having an option of subcontracting also. Any demand which I am not able to produce in house, I can go for the subcontracting also. And there is a capacity of 200 units in each quarter which is available through subcontractor, through vendors, which I can get fulfilled through subcontracting. Along with this demand data and the capacity data, we also need what is my opening inventory. I am having 100 units of opening inventory, and also keep in mind that I have to keep some closing inventory also. Whereas, in the previous spreadsheet method, we said that our opening inventory is 0 and closing inventory is also 0. But in this case, just to see that aspect also, you may have in the beginning of the planning period, you are having certain inventory and you want to keep certain closing inventory also for the coming planning period. And regular time production cost is rupees 100 per unit. Overtime production cost is rupees 120. As I said, overtime production cost is always expensive, and then the subcontracting is even more expensive. If you getting the item produced through subcontracting, the cost taken is rupees 170 per unit. And I also taken that cost of carrying inventory is rupees 10 per unit per quarter, per period or per quarter. In this case, we have taken quarter, so per rupees 10 per quarter. Now, let me first give you an idea about what is transportation model before putting before formulating this particular problem as a transportation problem. What is transportation model? As the name suggests, transportation model is used to find out how many units of a product to be transported from source to destination. For the example sake, let us say we are having 4 sources of production, you are having 4 factories or 4 sources of production, and you are having let us say for the example sake, you are having 5 warehouses. You are having 5 demand centers where the material need to be transported. So, these are destinations. So, in our transportation model language, we say sources and destinations. Each source has certain capacity, each source has certain capacity to produce. Let us say source A has a capacity of 500 units, source B has a capacity of 300 units, source C has a capacity of 700 units, and source D has a capacity of 150 units. Similarly, each destination has certain requirements. Each destination has certain requirement. Destination A1 has a requirement of 200 units, destination 2 has a requirement of let us say 400 units, destination 3 has a requirement of let us say 800 units, destination 4 has a requirement of 300 units, and destination 5 has a requirement of let us say 400 units. It is not necessary that capacity should be equal to requirements. We can have the dummy source and dummy destination if the we call it imbalance transportation problem, imbalance transportation problem, if transportation problem, if the sum of capacities is not equal to sum of requirements. Sum of requirement. If sum of capacities is not equal to sum of requirements, we call it imbalance problem, and we use the dummy source or dummy destination, whatsoever is the difference, we add one dummy source and we say that requirement or that capacity will come from that. Okay. So, that is one set of information which is required in our transportation model. Another set of information is the cost of transporting a unit from source A to destination 1. How much is the cost involved in sending one unit from source A to destination 1, let us say 3 rupees. How much is the cost of sending one unit of from A to 2, let us say 7 rupees, from A to 3, let us say 2 rupees, A to 4, let us say 5 rupees, A to 5, let us say 10 rupees. Similarly, from B to 1, let us say 8 rupees, depending upon their geographical location, the transportation cost per unit may differ. From B to this, let us say 4 unit, this to this, let us say 6 rupees, let us say this is 7 rupees, that let us say this is 5 rupees. Like this is let us say 4, 5, 2, 1, 8. Let us say this is 7, 5, 3, 6 and 4, like this. So, this is the data which is required for a transportation model. I should know what are my sources of the material and what are my destination of the material, and how much capacity is available at each source, how much is the requirement at each destination, and then what is the cost of sending the material from source to destination. In our case, we do not have the sources and destination, we are having different methods of producing the production. My sources are regular time capacity, overtime capacity, and then subcontracting. So, these are the 3 ways by which I can produce. So, these are my sources of production, and then this is in period quarter 1, in the same way in the quarter 2 and quarter 3 and quarter 4. Okay. So, I am having sources of production through in different quarters on a regular time, in overtime and in subcontracting, and then I am having demand in different quarters. I am having demand in different quarters. In quarter 1 I am having certain demand, in 2 I am having certain demand, in 3 I am having certain demand, and in quarter 4 also I am having certain demand. Okay. So, in our case we do not have that kind of a typical factories and the warehouses, we are our demand is in different quarters of the planning, and demand is also in different quarters of the planning, and in each quarter we are having 3 types of sources by which I can produce, that is regular time, overtime and the subcontracting. Okay. So, this is how this transportation model we are going to build up, and to solve this, though it is a full fledged topic in operation research, you can refer the book of operation research to understand more about the transportation model. And so, there you will find that several aspects of the transportation model and how to solve that is also available. Just to give you an idea, to solve the transportation problem, we are having 2-step methodology. We can follow 2-step methodology. In step 1, we find the initial feasible solution, using northwest corner rule, or Vogel's approximation method. And then in the step 2, we optimize using UV method or stepping stone method. Again I am saying that you refer some operation research book to understand more about transportation stepping stone method. We are having free software also available, you can download that also, that is Tora. Tora software is available, or there is another POM is another software which is available. You can freely download and you can fill this data into that and you can solve the problem. So, I hope you get some idea about what is transportation model. In the transportation model, we are having certain sources where the material is available, and we are having destinations where the material is required, and we have to see that how to match the requirements from the various sources of material. In our case, we have to see that how to meet the demand in different quarters by the production in different quarters from multiple sources. Multiple sources are regular time production, overtime production and subcontracting. Let us see that now. So, this is our question at hand, which we are trying to see that how to solve. So, we are having demand in 4 quarters given here, and we are having 3 types of capacity, that is regular time capacity, overtime capacity and subcontracting capacity, and these are some of the cost parameter which we will use to fill the body of the matrix. This information we will try to use for the these requirements. This is we will use for requirements, and this information we will use for capacities, and this information we will use for filling the matrix cost of producing and fulfilling the requirements. So, I have just copied the demand and the capacities here, so that you can understand better. I am having some opening inventory, that is my source of material, 100 units of opening inventory is available. So, that is my source of my sources, capacity available. So, these are my various sources in that way. Okay. So, these are my various sources of material available with me. Some inventory is available. Then in quarter 1, I am having a regular time capacity of 300 units, subcontracting capacity of 200 units, overtime capacity of 60 units. Similarly, in quarter 2, this is in quarter 1. Similarly, in quarter 2, I am having certain capacities of regular time, overtime and subcontracting. In quarter 3, I am having certain capacities, and in quarter 4 also I am having certain capacities available with me. And then there is a requirements demand. In quarter 1 I need 300 units as is written here, in quarter 2 I need 800 units, in quarter 3 I need 600 units, and in quarter 4 I need 200 units. Yeah, here I have to add 150 units, which is the closing inventory required at the end of 4 quarters. So, I have to add 150 units also, which is the closing inventory required at the end of 4 quarters. So, I hope you are clear how to fill this capacities and requirements in the transportation model. Now, these number which is the body of this we will see with the help of cost information. What is my regular time capacity cost, what is my overtime capacity cost, what is my subcontracting cost, and then we will see that how to fill the body of this, the cost parameters of producing in quarter 1 through a particular capacity and meeting the demand in different quarters, how this looks like. So, there is an opening inventory of 100 units. If you are consuming in first quarter itself, there is no inventory carrying cost. If you are consuming it in the first quarter itself, there is no inventory carrying cost. But if you are consuming it in the second quarter, there is a rupees 10 per unit per quarter is the stock carrying inventory. So, if you are meeting the requirement in quarter 2 from the inventory, the cost will be 10 rupees. If you are meeting the requirement of the in the quarter 3 of this opening inventory with the cost will be 20. If you are meeting in quarter 4, the cost will be 30 rupees. So, this difference is because of cost of keeping inventory. Every quarter the cost of keeping inventory is rupees 10 per unit per quarter. Now, come to the regular time capacity in quarter 1. If you are producing in quarter 1 and consuming in quarter 1, if you are producing in quarter 1 and consuming in quarter 1, the cost of carrying inventory is the cost per unit is rupees 100. Producing in quarter 1 through regular time capacity and consuming in quarter 1, that is rupees 100. On the other hand, if you are consuming this to meet the demand of quarter 2, the cost is 110. If you are using it in quarter 3, so this is 10 rupees is the inventory carrying cost, another 10 rupees is the inventory carrying cost, another 10 rupees is the inventory carrying cost. Same way, if you are using the overtime capacity, 120 rupees is the per unit per cost, with overtime 170 is the per unit per cost for the subcontracting, and 10 rupees is added this and like this. So, we are able to meet this, able to develop this for the quarter 1, and this was related to inventory. Okay. Now, this is the quarter 2. Since I cannot meet the requirement of quarter 1 by producing in quarter 2, so I have kept a very high cost, infinity. So, I have kept a very high cost which is higher than the any of the other cost by 5-6 times. So, I have kept a 999 as the cost of producing in quarter 2 and meeting in quarter 1. So, I have kept a very high cost because this is infeasible. This is infeasible cell. This cell is infeasible cell. It is not possible to produce in quarter 2 to meet the requirements of quarter 1. So, that is why all these parameters are you are finding are we have kept it as very large number because it is not possible. We have kept a very high cost because this is infeasible. Same way we have kept this number also very high because this is infeasible. This also we kept it very high because it is not feasible. You cannot produce in third quarter and meet the requirements in fourth quarter. It is not possible. So, we have kept it like this. Okay. Now, let us look back again. So, this is our quarter 1, this is our quarter 2, quarter 3 and quarter 4. Okay. So, this is how the cost matrix has been filled. This is your normal cost which is given 100, 120, 100 rupees is the regular time, 120 is the overtime and 170 is the. So, this is one, same way we have kept it here, same way we have kept it here and same way we have kept it here. And by adding rupees 10 we reach to these numbers, and if we add 2 plus 10 we reach to these numbers, and this 10 is nothing but cost of carrying inventory per unit per quarter, and by adding 10 we reach to this particular numbers, and same way here from to this plus 10 like this. Okay. So, like this. So, this is my cost matrix which we have filled. So, I have used this now matrix and used the software Tora to solve it, and you will see a very interesting results. So, this is the matrix which I am getting, answer I am getting. So, I will prefer to meet the requirement of 300 units of quarter 1 by 250 units of regular time and 60 units of overtime capacity. Quarter 2 requirement of 800 units, I will try to meet 100 units from opening inventory, 60 units by regular time capacity, and I am not using any overtime here, I am not using any subcontracting, I am using 400 of regular capacity here, 80 units of overtime and 160 units of subcontracting. Here I am I produced I produced 300 units, but I consumed only 240. So, 60 units I am using here. Okay. Here I produce 60 only. So, I am consuming here. So, nothing is required here. So, this is how I am meeting the requirement of 800 units here. Similarly, if we look at in quarter 3, we are producing in quarter 3 and we are consuming in quarter 3. We are not using any previous capacity, and in quarter 4 also we are producing regular time 300 and overtime 50 to meet the requirement of 200 units of demand and 50 units of closing inventory. And in that manner, the total cost of the system is 2,21,600 rupees is the cost of this particular aggregate plan. Cost of regular time production, cost of overtime production, cost of subcontracting and cost of carrying inventory. So, 2,20,000 is the cost of meeting this particular plan. So, this is how the earlier we have seen the spreadsheet, how the same kind of a situation can be solved using the transportation model. You can do the aggregate planning with the help of spreadsheet, you can do that with the help of transportation model also. The advantage of transportation model is you need not to explore the various strategies. All the various strategies you have built up in the transportation model, then you enter that in your Torah software, and with one click you will get the optimal answer. Rather than exploring the various different strategies and then seeing that which strategy leads to the minimum total cost, this gives the optimization. This transportation model is a optimization model. It gives the best answer, optimal answer. This gives the best answer, optimal answer. So, no need of exploring the various strategies. This will give you the best strategy, the optimal strategy, the best strategy under the given constraints and requirements. It will give you the best strategy. So, that is the advantage of transportation model, but obviously, the building up of this and understanding this and then using the software may be bit cumbersome, whereas in the organization everyone is familiar with the Excel sheets, etc. So, no special training is required in using the Excel sheets, and in Excel sheet you can very easily do the what if analysis also. In case of transportation model, if you want to do what if analysis, you may have to change the several parameters on this sheet, you may have to change the several parameters on this sheet, then only you will be able to see the impact of a particular aspect, whereas in spreadsheet you just change one number and you can see its impact at all the places. So, that is the pros and cons of the two different methods. So, depending upon the requirement, depending upon the situation, you can use that transportation model or spreadsheet. Now, coming to the third method, that is a linear programming method. This is also a optimization method. You can use any book on operation research, optimization method. You can use any book on operation research to understand this book, operations research. We can use the book on operation research to understand the linear programming models. So, I have taken another illustration for this purpose, the same which we are using for the transportation model, but only one change I have kept here to keep the thing simple. We are saying that we are considering the cost of carrying inventory as 0. So, you can produce in quarter 1 and use it in quarter 2, 3 or 4, there is no cost of carrying inventory. Just to keep the formulation a simple one, otherwise many more constraints would have been added if we are more. So, just to keep the illustration simple, we have made this assumption, but definitely we can include this also in formulating the linear programming problem. There is no limitation as far as the technique is concerned. It is only for the sake of illustration here. I have kept it as a nil here, 0 here. So, that several constraints which were related to that you are producing in quarter 1 and using in quarter 2, those we have reduced the number of constraints, and number of variables also are reduced. So, here we have taken the same data, we are having 4 quarters and we are having demand in 4 different quarters, and then there is a regular time capacity, there is a overtime capacity, and there is a subcontracting capacity available with us, and then there is a in different quarters we are having the demand to be met. What are the decision variables here? What are the decision variables here? The decision variables are how much material I should produce in with regular time in quarter 1. First decision variable is how much quantity I should produce with regular time capacity in quarter 1. So, x 1 in quarter 1 to quantity to be produced with regular time capacity. So, x 1 is in quarter 1 quantity to be produced with regular time capacity. X 2 is the quantity to be produced with regular time capacity in quarter 2. X 3 is the quantity to be produced in quarter 3 with regular time capacity, and x 4 is the quantity to be produced in quarter 4 with regular time capacity. Then I have taken x 5 as the quantity to be produced with overtime in quarter 1, quantity to be produced with overtime in quarter 2, quantity to be produced with overtime in quarter 3, and quantity to be produced with overtime in quarter 4. Similarly, 5, 6, 7 and quantity to be produced in quarter 6, quantity to be produced in quarter 7, quantity to be produced in quarter 8. Similarly, we are having variables x 9, x 10, x 11 and x 12. X 9 is nothing but quantity to be subcontracted in quarter 1, x 10 is the quantity to be subcontracted in quarter 2, and x 11 is the quantity to be subcontracted in quarter 3, and x 12 is the quantity to be subcontracted in quarter 4. So, like this. So, these are my decision variables. Other variables are I am having certain opening inventory, I need certain closing inventory, and at the end of each period we are having certain inventory available. So, I 0 is the opening inventory, I 1 is the inventory at the end of the period 1, I 2 is the inventory at the end of period 2, and I 3 is the inventory at the end of period 3, and I 4 is the inventory at the end of period 4. So, these are my inventories at the end of various periods. So, with the help of this I can develop, and let me give you a brief about linear programming model also, just like I gave you the brief about transportation model. Before applying this data to the linear programming problem, before developing the linear programming model, let me give you what is linear programming model, and more detail, as I said, you can read any operation research book, linear programming problems you will find there. Let me give you a brief about the linear programming problems. This is also a topic in operation research. This is optimization model, where we are having a objective function, Objective function can be of maximize type, maximize z, where profit is there, or it can be minimize z, where cost is there as a objective. And then you are having constraint, we call it subject to the constraints, okay, subject to the constraints. So, we can see that various constraints can be there. Like we can take a case when we say maximize z, let us say you are producing tables and chairs. You are producing two types of products, tables and chairs in a factory, and you are using 3 processes, process P1, P2 and P3, and each table is giving you a profit of, the 3 processes are involved, P1, P2 and P3. Each table is giving you a profit of, let us say 100 rupees, each chair is giving you a profit of 150 rupees. Okay. And to produce a table, let us say 2 hours of this is required, 3 hours of this is required and 1 hour of this is required. To produce one chair, let us say 1 hour of this is required and 2 hours of this is required and 5 hours of this is required. And let us say you are having 200 hours availability. You are having 200 units hours of P1 is available, 300 hours of P2 is available and 250 hours of P3 is available. Now, our objective here is maximize profits. Objective here is maximize the profit. So, I will write that maximize Z. And what are my decision variables in this case? Just like we have identified the decision variables. Decision variables is how much quantity of tables and how many chairs I should produce. X1 is the number of tables to be produced, and X2 is the number of chairs to be produced. So, what is my profit? Maximized profit is, each X1 gives me 100 rupees. So, my profit is, function is 100 into X1 plus 150 into X2. So, that is my objective function. What are my constraints? What are my constraints? My constraint is, I cannot consume more than 200 units of resource P1. I cannot use more than 200 units of resource P1, and each X1 required 2 units of P1 and each X2 require 1. So, 2 X1 plus 1 X2 should be less than or equal to 100. Similarly, 3 X1 plus 2 X2 should be less than or equal to 300. Similarly, 1 X1 plus 5 X2 should be less than or equal to 250. Okay. And further, I cannot produce negative number of chairs and tables, they are greater than or equal to 0. So, like this. So, this is the formulation of a linear programming problem if it is a case of maximization. In the same way, if the problem is related to cost where I have to minimize the cost, I can formulate it as a minimization problem also. So, now we are coming back to our topic, our own illustration which we are talking about. So, here our job is to minimize the total cost of meeting the demand. Our objective is to meet this demand with a total minimum cost, and my alternatives which are decision variables are x1 to x12 are my decision variables. So, I have to decide how much quantity I should produce with regular time in different quarters, with overtime in different quarters and by subcontracting in different quarters. So, that is my job here. That is what we have to calculate, and certain cost parameters are given to us. Now, let us see how to formulate this problem. So, I will write that minimize Z, 100 is the per unit cost of producing through regular time, 100 is the per unit cost of producing with regular time, 100 into x1, x2, x3 and x4, sum of x1, x2, x3, x4. These are the regular time productions in different quarters, in quarter 1, quarter 2, quarter 3 and quarter 4. Okay. Similarly, we are producing through overtime at the cost of 120 unit, rupees 120 per unit. So, rupees 120 per unit x5, x6, x7 and x8. Similarly, 170 is the cost of subcontracting x9, x10, x11 and x12. So, that is my cost of subcontracting. Okay. And my constraints are, as we have said, that I should produce minimum 300 units in quarter 1 by with the help of regular time, with the help of overtime and with the help of subcontracting, and I am having certain opening inventory available with me that can also be used here. So, I can use that opening inventory. So, this my production in the quarter 1, this is my production in the quarter 1 should be more than 300. Generally, if the objective function is minimization type, constraints are greater than type. if and vice versa, if the objective function is maximization type, the constraints are of less than type, whereas if the objective function is of minimization type, constraints are of greater than type. So, similarly, this is the production requirement in quarter 2, this is the production requirement in quarter 3 and this is the production requirement in quarter 4. Okay. So, this is the production requirement in quarter 4. So, friends, this first constraint, the first equation is related to period 1. I should produce the x 1, x 5 and x 9, that is regular time production plus overtime production plus subcontracting minus opening inventory should be more than 300. Similarly, x 2, my regular time production plus overtime production plus subcontracting minus any surplus which was there in quarter 1 should be more than 800. In quarter 3 same manner and in the quarter 4 also. This is though the requirement 200, but I need a closing inventory of 150. So, that is why this number has become 350, otherwise this quarter 3 requirement is 600, quarter 2 requirement is 800, quarter 1 the requirement is 300. So, this is how. So, friends, also you will find that if the objective function is minimization type, you will find most of the constraints are of greater than type. In our case, all constraints are of greater than type. On the other hand, if you see in the previous case, when we are talking about maximization type, there you might have observed that if the case was of maximization type, the constraints were of less than type. Okay. I cannot consume more than the given resources. Here I have to produce more than the required demand. Similarly, I have a constraint that I cannot x 1 cannot be more than 300, x 1 cannot be more than 300, x 2 cannot be more than 400, x 3 cannot be more than 400, x 4 cannot be more than 300. That is my regular time capacity. These are my regular time capacities, x 1, x 2, x 3, x 4 cannot be more than that. In overtime capacity, so these are related to overtime capacities. I cannot exceed the capacity available 60, 80, 80 and 60 units, and these are related to subcontracting. I cannot have more than 200 units of subcontracting in different periods. Okay. So, this is how we can formulate the given problem as a linear programming problem. So, you can solve it using any software also, manually also. Tora can be used to solve it. In Excel also we are having solver to solve linear programming problem. So, I am not solving it here, I am leaving it to you to solve it using Tora or solver here, but after having this formulation you can use any software or manually also, though with so many variables and constraints manually it may be difficult. So, use the Tora or solver to solve this problem. Friends, so these are some of the illustration which we have discussed. Now, let us see means if there are diverse product in the same system you are producing different types of products, it can be window AC and split AC or different types of products, then how to do the aggregate planning. What is required is we have to convert both the types of products into the same common scale. It can be in terms of requirement of labor or machines, etc., because you have to bring the outcome or demand on a single scale, single parameter. It can be in terms of labor, it can be in terms of machines. In such cases, demand rather than expressing a unit per month, we have to express in terms of manpower or machine hours per month. So, we cannot, because units per month different types of products are there which may require different manpower and different machines. So, we have to see that I have to convert into a scale, input scale. We have to consider the production capacity also in aggregate planning. In product focused systems, capacity is usually determined by the output or the last operation, or it can be the first operation. Whereas, in the process focused production system, we can see the bottleneck stage or the step which is having the least capacity, that can be should be considered in finding the capacity of a process. If the manufacturing system has many stages. So, which stage capacity, and each stage is having obviously a different capacity. So, which stage to be considered In case of product focused, we can consider the first stage or the last stage where the output is coming, and in certain other system where the products are totally unstandardized, maybe we can consider the capacity in terms of labor hours or in terms of machine hours of a department or a entire factory. So, we can convert it into a capacity also in terms of labor hours. Just like we have converted demand into labor hours, same way capacity can be converted into labor hours in that case. Coming to the touching the topic of services also, that is also in production and operations management, an important aspect which we have to consider the services also. The unique feature of services is they need to be consumed when they are produced, and demand for services is more random, more variable, and the capacity availability is also difficult to predict, just like in a restaurant, etc. And labor, but advantage is you are having a labor flexibility, very less equipments are there. So, there is advantage in the that. So, what we can do, difficulty in service system is we do not have any finished goods inventory available. So, I cannot have inventory and backlog option in case of services. So, there is no buffer between the demand and the capacity, but you can keep the buffer not in the form of inventories. Buffer is not possible in the form of inventory, but you can keep the buffer in terms of surplus capacities. In case of services, we keep the buffer in the form of surplus capacities, maybe few additional machines, few additional manpower or like that. So, we keep the buffer in the form of surplus capacity rather than in the form of inventory. A service system providing standardized service to customers like restaurants, etc., airlines, trucking, etc., aggregate planning is similar to the production system. Whereas service systems which are providing customized services like hospitals, automobile repair shops, etc., we can follow a two-step approach. In the step 1, we can develop the aggregate plan demand forecast in some homogeneous unit measurements such as labor hour, machine capacity, and in step 2, we can try to discover the common denominator unit of capacity. Demand is also converted into a homogeneous unit, and denominator capacity is also converted into some homogeneous unit, and then we will try to see that agreement demand with the production requirements. And then also we can develop some in services innovative method to expand capacity. Not only subcontracting is not there here, we can have some standby workers. As I said, we can keep some additional workers with us or additional machines or buildings, etc., also which can be activated during the peak demand periods, and may be possible for restaurants, etc., for the purpose of producing. You can have some contracting or outsourcing also as a means of expanding the capacity. So, friends, this was a small discussion we had on aggregate planning. There we discussed the purpose of aggregate planning, how this is a part and parcel of a bigger concept of production planning and control. There we also seen that what are the various options available with us: proactive strategies, reactive strategy, chase strategy, and level strategy, mixed strategies also. And then we have seen the 3 techniques also: separate sheet method, transportation model, and the linear programming model, to model these system, model this production aggregate planning issue, and try to find out the mix or the optimal solution to minimize the cost. So, with this we close this particular section of aggregate production planning. Now, the output of this aggregate production planning we are going to use for the material requirement planning. So, we will in the next unit we will talk about material requirement planning. Thank you very much.